Today's goal is to get much better at graphing exponential functions and logarithmic functions. So we're not going to be focusing on exponential growth and decay. We're going to be talking about, well, what happens when these things have been shifted and stretched and shrank all over the world? How do we graph, scarier looking exponentials, and how do we graph scarier looking logarithmics? And then even scarier, let's keep using that term, than that is, what if I give you a picture of a graph? Can you come up with its ugly equation? It's only ugly because of all the transformations. That's what we're going to be doing today. We're going to be focusing on learning how to be better exponential and logarithmic graphers. All right, let's see. Grab the old stylus. Pretty sure I'm recording. Can't guarantee it, but yeah, okay, cool. Recording, great. All right. So I've started with an exponential function that's got 1, 2, 3 transformations in it, all right? And in order to be successful at graphing exponential functions, you need 3 things. The first thing you need is, where did the horizontal asymptote end up? You see, the horizontal asymptote of an exponential growth or decay function, which this is not growth or decay function, it's just an exponential function. The horizontal asymptote is supposed to be the x-axis at y equals 0. That horizontal asymptote only changes if we shift our graph up and down. Because if you shift the graph up and down, you're also shifting the horizontal asymptote up and down. So if you see a vertical shift at all, then you know that you have a different horizontal asymptote. So then this number that is added or subtracted to the end, this is your new horizontal asymptote. So I'm going to go ahead and throw that on there, y equals 3. You do need to identify this as an exponential. That way you know how it's shaped. You know that it's not going to have a logarithmic shape. It will have an exponential shape. But you only need 2 coordinates. Once you have 2 coordinates, you just connect your dots and get really close to the horizontal asymptote on one side and go away from it on the other. And ta-da, done. So what are the 2 coordinates that you should be hunting for? There are 2 easy trackable points. And those 2 points are going to be found by asking yourself, what makes the exponent equals 0? Because, if the exponent's 0, then that exponential expression has a value of 1. So what makes our exponent equal 0? 2, yeah. So we have a 2 there. You would just identify the y value that goes along with it. So let's do that in another color just so it's not confusing. We have y equals -2. I dropped a 2 in. Do you have to show this work? No. If you can do it in your head, by all means. What this is going to give you is -2 raised to the 0 plus 3. You need to be really careful here, because -2 raised to the 0 does not equal 1. It equals -1, because that negative sign is not inside parentheses. You have to follow the order of operations. Only the 2 has an exponent of 0. So this is going to give you -1 plus 3, which is 2. So you have a coordinate at 2, 2. And the other x value that you're hunting for, the easy x value that you're hunting for, is what makes the exponent equal 1. That's going to make your life very easy. What x value makes our exponent equal 1? Yeah, 3. Yeah. So we have to plug that in. We do it the same way. Y equals -2 raised to the 3 minus 2 plus 3. Okay. That gives me -2 to the first, which is -2, plus 3, which is +1. So 3, 1. puts us here. And that's enough for you to figure out what this thing looks like. But for some reason, it's not drawing anything. Wow, okay. Let's see if it can do that without having a stroke. There it is. Ta-da! What do you think? Scary hard? Not bad, right? You figure out what your horizontal asymptote is, basically just by saying what numbers add or subtracted at the end. And then you need 2 points. Those two x's are going to be the x's that make the exponent equal 0 and the exponent equal 1. If you wanted more points, you could always make the exponent equal 2 if you wanted to. That'll be at 4. And that'll be 4 comma negative 1. I missed that point, but it's not necessary. It's just a sketch. It's just a rough sketch. Okay? Questions, comments, concerns, criterions? No? Good? All right. So now I've got this box of information, and it's got a whole lot of stuff going on. And it's telling you, how can you find the equation of an exponential from its graph? And you know what? I'm going to teach it different this year. I'm going to disregard most of what's in this box. And the reason why is because it requires my students to memorize too many things. I'm not a big fan of memorization. I'm a big fan of understanding. So what's in this box is a bunch of tricks that I just noticed, a bunch of patterns I noticed that are true because of transformations. But even I don't remember all my own rules. So if I was going to teach it that way, I would have had to have studied my own crap before I taught it to you. And I don't like that. I don't like that idea. If I am having trouble memorizing it, I'm assuming my students would have trouble memorizing it as well. So I'm going to tell you the most important thing that is in this box. In fact, the only thing that matters in this box is the horizontal asymptote. That's all that matters. You just look at the graph, identify the y value that it's approaching, because that is always going to go here. The rest of it, we're just going to use basic algebra skills and systems of equations. Don't worry, it's a lot easier than it sounds. Okay? Just go with me on this. Should you feel the need to memorize all of this stuff, go for it. If you've got a memory like a safe and you won't forget, okay, fine. Memorize this stuff. But I just don't like memorizing things, so skipping right over that memorization stuff. Instead, I'm going to look at this graph and I'm going to see that, yeah, that's definitely an exponential. And I recognize it as an exponential because I can see that it has a horizontal asymptote that it's approaching. That I know. And that is happening at the line y equals 4. So when I go to write this exponential, I'm going to assume that it's an easy one and that it does not have a shift to the left or right. But I am going to write that plus 4. Now, I'm probably wrong about there being a shift left or right. I'm probably wrong about that, but it's okay. Just go with me on this. What you want to do is go to your graph and identify two, you see it's, again, two what I like to call pretty points, things that are obvious. So I see a pretty point right here, and it looks like the next pretty point happens here.
-1, -2.
I'm sorry?
Oh, I thought you asked where's another one.
Yeah. So I've got one at -2, comma 2, and I've got another one at -1, -2. And I'm going to use those two coordinates to solve for my unknown A and my unknown B, and it'll actually show me what the unknown horizontal shift is as well. Those are those are x comma y's. So you can plug them in as x's and y's. So I'm going to plug in the first point, negative 2 comma 2. So I get 2 equals ab to the negative 2 plus 4. And I'm going to plug in the other coordinate, building a system of equations. Negative 2 equals ab to the negative 1 plus 4. Before I move on, are you all comfortable with what I'm doing right now? Do you understand what's happening? I'm building a system of equations with 2 known coordinates. And I'm going to use those systems of equations to solve for my 2 unknowns, a and b. And then through some clever manipulation using exponent rules, we'll actually find a horizontal shift as well. See, on the left one, subtracting 4 from both sides gets us negative 2 equals ab to the negative 2. On the right side, subtracting 4 from both sides gets me negative 6 equals ab to the negative 1. I'm trying to use a system of equations, but I don't want to have to substitute in for a or substitute in for b. I feel like that is too much work, to be honest with you. Instead, I would like you to notice, that if you multiplied this equation by 3, it would say this, negative 6 equals 3ab to the negative 2. And this one still says negative 6 equals ab to the negative 1. Because they both say negative 6 equals, I can set them equal to one another. This is just an Algebra 1 concept in a really, really weird use. Systems of exponential equations, something you've probably never done before. But you can set them equal to each other since they both say negative 6 equals. So 3ab to the negative 2 equals ab to the negative 1. Sorry, I lost where I was for a moment. You can divide both sides by a and watch what happens. Just divide both sides by a and they cancel out, bless you. 3b to the negative 2 equals b to the negative 1. And what you could do now to isolate the b's is get this b to the negative 2 off of the left side. It's really strange to say divide by b to the negative 2. That's a weird thing. So instead, what I'm going to do is multiply both sides by b to the positive 2. Remember, when you multiply two numbers with the same base, you add their exponents. So multiplying those two things would give you b to the 0, which effectively would cancel b off of that left side. And that's why I'm able to multiply both sides by that b to the positive 2. Yeah, I'm waiting for the board to catch up with me. There we go. You mean scroll down so you can see more? Yeah, so let me extend the page a little bit. How's that? All right. If I move too fast, the computer freaks out. So like I said, I was multiplying both sides by b squared. On the left side, when you multiply two numbers of the same base, you add the exponents, positive 2 and negative 2. That's gone. On the right side, when you multiply two numbers of the same base, you add their exponents. Negative 1 plus 2 is positive 1. Oh, look, we found our exponential base. It's 3. We should say all that effort for b? We haven't done anything yet. We haven't found a yet. Now, look, if you feel like this is too much work, by all means, memorize all that stuff in that box. But bet money you won't remember that stuff in that box at the end of next chapter. You're going to forget it. But we all know how to plug in x comma y and solve systems of equations. See, that's why I've chosen to teach it this way this year. Okay, now that we know what b is, we can use it to solve for a. So I'm going to take that b value of 3, and it doesn't matter which one I go to. Oh, look, Kristen's here. It doesn't matter which one I go to. I can plug in that b value of 3 to either one of my two things that I have. And because it's there and it's easy pickings, I'm going to go right here. I'm just going to plug in b equals 3 right there. You guys okay with that? Where that green dot is? Or, you know what? I could even plug it in. It really doesn't matter. Oh, you know what will be even easier? Yeah, here. Let me plug b equals 3 in right there. Why, Mr. M? Because the power of that b is a 1. I know it's a negative 1, but it's just a 1. We okay with that? Great. So I'm taking that, I'm coming down here, and I'm plugging in b equals 3. Negative 6 equals a to the, or a times 3 to the negative 1. Again, I could turn this into a fraction and whatnot, or I could just get rid of that 3 to the negative 1 by multiplying both sides by 3 to the positive 1. Because when you multiply two numbers with the same base, you add their exponents. That's going to cancel the 3's on the right side. And on the left side, I get negative 18 equals a. And you're like, woot, a is negative 18. But wait a minute. That's a really big number, isn't it? Wouldn't that imply that there's some kind of ridiculous vertical stretch going on? Okay. I've never had you graph anything like that before, have I? No. Here's the brain stretch that I'm asking you to have. I'm asking you to realize that your exponential base is a factor of a. I would like you to write a, instead of saying it's negative 18, I would like you to say it's negative 2 times 9, which is 3 squared. Could we just leave it as negative 18 times 3 to the x plus 4? We could, but that is not what it's going to look like on the test. It's going to look more like that thing that we saw up at the top where I taught you to graph it. It's going to look like that, a nice small a value. So when you write the full equation, let me scroll down. When you write the full equation, it's going to say y equals negative 2 times 3 squared times 3 to the x plus 4. It was plus 4, right? Okay. And then last but not least, when you multiply two numbers with the same base, you add their exponents. So y equals negative 2 times 3 to the x plus 2 plus 4. That's the best way to write that equation. Was it a lot of algebra? Yes. But my question to you is, was any of the algebra difficult? No. The hardest part about this, in my opinion, happened right here. Because you don't want to leave an 18 on the front of that because it would really be a nightmare to graph. But a 2 on the front, no big deal. Okay? That number, that a value, should always have the base, the exponential base, as one of its factors. So you just factor it. And then you can, I don't want to say combine like terms, but then you could multiply two numbers with the same base, and that will show you the horizontal shift. Yes, that's a lot of algebra. I'm not going to say it was a quick question. But bet money at the end of the year, you would still be able to do what I just did. Would you still remember all the crap in that box? Probably not. Okay? So before we flip it over and go to the logarithmic stuff, I throw it out there and say, do you have questions for me on what just happened? Yes, please. Yes. Yes, I multiplied it by 3. That way both of my equations would be equal to the same number. Because once they're equal to the same number, I can set the two equations equal to each other. If you're not comfortable doing that, what you could do, and I don't want you to because I think it's more work, is you could have right here, instead of multiplying by 3, you could have multiplied both sides by b squared, which would have gotten a by itself. Then you could have substituted that a value into the other equation. It's not, and is it more work? Is it less work? I'm not sure. To be honest with you, I haven't tried. I've only done it this way. but the other way would work as well. Substitution would work just fine. All right, then I'm going to clear it, and we're going to flip it over, and oh boy, if you thought that was rough. Now, graphing exponentials, not too bad. And you know what? Graphing logarithms, also not too bad. Because there's 3 things you need. It's asymptote and 2 points, just like an exponential. So graphing them is pretty darn easy. Your asymptote is going to come from the fact that logarithms have a restricted domain. Remember, you cannot take the log of a 0. So your vertical asymptote is always going to happen at what x makes the inside equal 0. Because that is not allowed. You cannot have a 0 as an argument. The argument must be positive. So whatever number makes the inside equal 0, vertical asymptote. Now we need 2 points. The 2 points that we are going to find, the 2 x values, are the 2 x values that force the special logs. Remember, the special logs are log base b of 1 equals 0 and log base b of b equals 1. We are going to force those 2 scenarios. So the first question is, what makes the argument equal 0? Excuse me, it's not allowed to equal 0. I'm sorry, we already did that. Sorry. 1. What makes the argument equal 1? There we go. Because we're trying to force the first special log. So what makes that argument equal 1? -3. -3 does. So let's see what we get when we plug in a -3. We get -2 log base 2 of, oops, -3 plus 4 plus 2. So y equals -2 log base 2 of 1 plus 2. Well, log base 2 of 1 is 0. So what that says is -2 times 0 plus 2, which is 2. So the first of 2 coordinates we need is at -3, 2. And the other one, the other special log, is what makes the argument equal base. Okay, not only is the computer having a stroke, but the math teacher is as well. What makes the argument equal base? Well, our base is 2. So what x value would I have to plug in to get a 2 in the argument?
For the line right above that, how did you get -2 log 2 to +1 equals 0?
Well, because this right here has a value of 0 because of this up here. That says -2 times 0.
Oh.
Cool?
Or cool.
Okay. Do it one more undo. Trying to make that line go away underneath the log base 2 of 1. One more undo. One more undo. There we go. We found it. Alrighty. Let's see. We know that we're going to have to plug in x equals -2 to make our argument equal our base. So we go y equals -2 log base 2 of. Of course, here's me evaluating when I plug in the -2. I feel like this step was kind of redundant because we already know we have forced the argument to equal the base. So if you wanted to skip over that step and go directly to this step, I wouldn't blame you. Wow, that's a lot of 2's. Well, log base 2 of 2 is 1. So what this says is -2 times 1, which is -2, plus 2, which is 0. And the phone is ringing. Let me just pause the recording. Alrighty, now that we're off the phone. The second coordinate is -2, 0, which is right here. And that gives you enough knowledge to know what this thing looks like. Doing this-ish, like that. Ta-da! So graphing logs also should not be that bad. And remember, I showed a lot of work. I don't expect you on your homework to write what makes the argument equal 1. I really just expect you to do a lot of this math in your head. Okay? Focus. I know my phone rang, but refocus because we're about to do the harder stuff. Do you have any questions about graphing the logs before we move on to the writing the equations of the logs? It's a little more in-depth than writing the equations of the exponentials. Mentally, not algebraically. No? Okay. All right, well then let's move on. So once again, here's a box of tricks that all work and tell you what the equations of logarithms are based on transformations. And you know what? I don't even remember my own tricks. I honestly don't. These are not in your textbook. There's a reason why I had to make these supplemental notes. These things are not in your textbook. But if I don't remember my own tricks, you know what? I don't really expect my students to remember my tricks. So I'm going to use algebra skills rather than tricks to find the unknown parts of this graph. Once again, the only thing in this box that you must know, vertical asymptote. Because that vertical asymptote is going to be the number that makes the inside equal 0. The vertical asymptote is supposed to be the y-axis. So if it's not the y-axis, clearly your graph has been shifted somewhere, left or right. You cool with that idea? Make sense? So disregarding the rest of that stuff and coming on down. I'm going to go ahead and throw the dotted vertical asymptote on there. Do you have to? No, but I literally think that makes life easier. So, oh, yeah, that's an x equals 2. So what I know is that 2 makes the inside equal 0. This is what I know. Calm, cool, and collected about that. Yes, no, maybe so? Okay, we're good on that. All right. Okay. You see, 2 could make the inside equal 0 in more than one way. The inside, the argument, could be x minus 2 or 2 minus x. Does that make sense? 2 makes both of those equal 0, right? You need to, and this is why I said it's not hard algebraically, it's hard mentally. You need to make the choice right now which one you want to use, and you need to use your knowledge of transformations to pick it. You should be aware that log graphs are supposed to go to the right. This one's going to the left. So is it going to be the first expression or the second expression? It's going to be the second expression because this logarithm is pointing the wrong direction. Because it points left, this is going to be the argument of your logarithm. Because it points left. I mean, I'll even points left. So that's knowledge of transformations. We already know then that we have something like this. Y equals A, because maybe there's a vertical stretch or shrink, log base B. We don't know our logarithmic base. But we do know the argument is going to be 2 minus x. And you know what? Whew, there may be a vertical shift. Man. All right. The first thing we did when we were trying to hunt down our equation on the last one after asymptote was we found 2 pretty points. I want you to do the same thing. Find 2 pretty points. There's one at 1, -1. And this is the next one, -4, 3. On your test, I put big dots on the pretty points that I want you to look at. I'm not leaving it up to you. I put them on there. Now, I didn't put the coordinates on there, but I'm hoping you can all read coordinates. Okay, so we're going to build basically a system of equations again, kinda, sorta. When I was doing the exponential, I don't know if you noticed, or maybe you just thought whatever, that was arbitrary, but the first point that I plugged in as x and y was the one that was closest to the asymptote. That wasn't arbitrary. You should always start with that one. Do you have to? No, but it'll make life easier. It really will. So I'm going to start with the one that's closer to the asymptote, the 1 comma negative 1. Negative 1 equals a log base b 2 minus, negative 1 . Oh, I'm sorry, 2 minus, shoot, did I break my computer? Stomped on the cord, hold on. Sorry, it's not negative 1, that's a y value. My apologies, I'm just tired. Come on, computer, please, please. There we go. 2 minus positive 1, there we are. That makes more sense. And then plus k. Well, okay, let's do some simple maths. A log base b of 2 minus 1 is 1. Wait a minute. What does log base b of 1 equal? This equals 0. So what they have here is negative 1 equals a times 0, which is 0, plus k. Look at that. Plugging in the point closest to the asymptote immediately shows me my vertical shift. How about that? My k value must be negative 1. So again, I'm going to write what I know about the equation so far. I know that I have y equals a log base b of 2 minus x minus 1. So you're looking at this and you're going, I don't know, Mr. M. You still have 2 unknowns, and you only have 1 more coordinate to work with. I know. Watch this. I'm going to plug in negative 4 comma 3. 3 equals a log base b of 2 minus negative 4 minus 1. And allow me to stretch the page a little bit so my people in the nosebleeds back there can see what I'm writing. Having to go painfully slow here. Okay. I'm going to add 1 to both sides. Hopefully you guys are cool with that. And 2 plus 4 is 6. How about that? What would make life really, really easy about that logarithmic base? Oh, if it was base 6, that would make life easy, wouldn't it? Okay, so base is 6. And here's why we're going to do that. He's like, wait, we could just do that? Here's why. Remember when I told you how you were going to graph these things? The second point's job was to make the argument equal the base. The argument is 6 right now. That was the second point. The base must be 6 then. How is it going to land on a pretty point unless you had an integer value? It had to be an integer value there. So the base must have been 6. Okay, so if the base is 6, you have 4 equals a times log base 6 of 6. And what does log base 6 of 6 equal? Yeah, it equals 1. Oh, a is 4. Okay, and we're finished. Y equals 4 log base 6 of 2 minus x minus 1. Ta-da! So it was less algebra than the exponential, but it did require a little bit more brain work. Had to understand some transformations and had to kind of logic your way through the fact that the coordinate landed on a pretty point. that meant the logarithm had to have a pretty value. It couldn't be some irrational mess. Well, the only way that was going to happen was if the base and the argument shared a common base. Oh, 6. Done. Just like that. But do you have questions about this process? I'd be more than happy to help you with it. Again, this you don't like, then you are welcome to memorize the tricks in that box. I will not hold it against you if you choose to do that. I could just tell you, you won't remember them next chapter, let alone next year. Next chapter is, well, every chapter is pain. I don't remember chapter 4. Trig, maybe? Maybe we start trig soon? Everybody that just said they were so happy about trig. Lol, let me ruin it for you. Okay, everybody. That was fun.